Hello and welcome to Laws of Logarithms Part 4. I'm just going to wrap up a few important little extras here, and then we're getting real close to the end of the whole business of logarithms. So, log of 17 base 5. How do we solve that? Well, we have a thing called the change of base formula, but I'm going to show you in the process of getting there. So I'm going to go back to developing that change of base. I'm going to show you an interesting little twist. So let's change this to its exponential counterpart, which is 5 to the something equals 17. Okay, and at this point was when we said, hey, let's take logs of both sides. So I could certainly do that. Log of 5 to the something equals log 17. Now here's the thing. Who says it has to be log base 10? You know, we can pick any base we want. Now some bases are more desirable than others, and most of the time it's going to be base 10. But at this stage of the game, I'm going to put in a B here because really nothing says it has to be any specific base. So I'm just going to leave that open for now. Then we took the unknown exponent, brought it out front. Okay, so here's what we have on our equation. And then finally, to solve for this unknown quantity, I divided by the log of 5 base b. So here's how we solved. Now, when we did a similar question earlier, I did this and I made sure it was base 10, just because that's handy and it's on our calculator. But now, let me show you what kind of possibilities exist with this. If I wanted to, okay, I could do something kind of funny, like what if I decided to make it base 17? So I would do this. So I'd have base 17 of 17 all over log of 5 base 17. Now that would look kind of strange because remember in the original question it said log of 17 base 5, and I could solve for it and it could look like this. 1 over, because log of 17 base 17 is just 1. I can do kind of a switcheroo on the whole thing. See, I could do something like that. So look at that. Log of 17 base 5 is the same thing as 1 over log of 5 base 17. Kind of do a little switcheroo number. Although that wouldn't help me find out what the actual answer is, it's kind of a cool little result. The other thing I could do, so it's sort of a separate one here, is I could choose a base that we haven't really talked about yet, and that is this base here. It's a strange little number called e, and it's kind of one of these little numbers that it's kind of like pi. It's one of these special math numbers. And so what if I chose to use base e? And you might say, well, that's no good. That's not even on my calculator, but actually it is. When you're dealing with log and its base e, it's called natural logarithm. And the only reason it's called natural is because when you take calculus, it definitely is the preferred choice for mathematicians. It's the natural choice. So if you look on your calculators, there is a button called LN, and it stands for natural logarithm, which is the same as log base e. You would get the same number if you went natural log of 17 divided by natural log of 5, or you could go base 10 of 17 and divide that by base 10, using base 10 log of 5. So log 17 divided by log 5, or natural log 17 divided by natural log of 5. So those are just some little extras there. So let's just summarize these extras up for you. So these are the little extra bits and pieces. First one that we sort of showed you was, suppose you have log of A and its base B, you can do a kind of a switcheroo thing by doing this. You can go log of b and base a, as long as it's 1 over that. So you can do a little switcheroo. Let's see. And then we talked about the special number e, which basically, if someone says natural log of something, that means the same thing as log base e of that something. So those are the little extras so far. I have one more little extra here that sometimes creeps up out of the woodwork. And it basically says, suppose you have b, and you raise it to the following exponent, log of x base b. And it says, well, what does that equal? Okay. This one can be a little bit tricky to kind of think your way through. So, whoops. So we have a little trick. My x isn't looking too good there. Let's fix that up a bit. There we go. I have a little trick, and it all stems back to, remember when 10 squared equals 100? And the logarithmic way of writing the same relationship was to say log of 100 base 10 equals 2, right? These are both statements of the same information. Let's take this and follow this as a guide and rewrite it from this sort of power form to a logarithmic form. So log of something, blah, blah, blah. All right, let's start with this 100. Where did this 100 come from? It was the stuff on the right. So that's the box. So that's what has to go in there. And then the 10, that's the base of this power here. So that would be a b. So that's going to equal b down there as the base. And the 2 is the same as the exponent up here. So this whole exponent gets written on the right side. Okay, so just writing out the exponent here. Now, when I look at these two things, what must this box hold in order for the left side to be the same as the right side? I got a log base b of x. I think that's got to be equal to x. That's kind of a really cool little relationship here. If you have some sort of a base number, b for example, and then you have it raised to the log base b, then whatever this is what the whole thing will equal. So if you saw it written something like this, somebody comes along and says, I got 7, and then I got log base 7. It doesn't matter what I put in the brackets, that's what the whole thing equals. You know, if somebody put in here, let's see, x squared minus 1, well, by golly, that is what this has to equal. So it's kind of a cool little relationship. And you know, it's a good thing to just put in the back of your mind. And that's where I'm going to stop.